Electronic cigarettes generations. E-cigarettes come in many variations, such as cigarette-shaped, pen-shaped, and tank-shaped styles. Some e-cigarettes look like traditional cigarettes, but others do not. There are three main types of e-cigarettes: cigalikes, looking like cigarettes; egos, bigger than cigalikes with refillable liquid tanks; and mods, assembled from basic parts or by altering existing products. E-cigarette components include a mouthpiece, a cartridge, liquid storage area, a heating element/atomizer, a microprocessor, a battery, and some have a LED light on the end. E-cigarettes are sold in disposable or reusable variants. Most versions are reusable, though some are disposable. They range in cost from under $10 to over $200. An entry-level reusable e-cigarette costs around $25. Disposable e-cigarettes are discarded once the liquid in the cartridge is used up, while rechargeable e-cigarettes may be used indefinitely. Even with rechargeable cigarettes, pod-based systems, however, there is a risk of littering. However, there are some thoughts on how to prevent pods from ending up in the environment, i.e. a deposit system for e-cigarette pods, and we should remember that cigarette butts currently also pollute the environment. One-piece devices are normally disposable. E-cigarettes are typically designed as 1, 2, 3, or multiple pieces. A disposable e-cigarette lasts to around 400 puffs. Reusable e-cigarettes are refilled by hand or exchanged for pre-filled cartridges, and general cleaning is required. A wide range of disposable and reusable e-cigarettes exist. Disposable e-cigarettes are offered for a few dollars, and higher-priced reusable e-cigarettes involve an upfront investment for a starter kit. Some e-cigarettes have a LED at the tip to resemble the glow of burning tobacco. The LED may also indicate the battery status. The LED is not generally used in personal vaporizers or mods. First-generation e-cigarettes usually simulated smoking implements, such as cigarettes or cigars, in their use and appearance. Later generation e-cigarettes, often called mods, PVs, personal vaporizer, or APVs, advanced personal vaporizer, have an increased nicotine dispersal performance, house higher capacity batteries, and come in various shapes such as metal tubes and boxes. They contain silver, steel, metals, ceramics, plastics, fibers, aluminum, rubber and spume, and lithium batteries. A growing subclass of vapors called cloud chasers configure their atomizers to produce large amounts of vapor by using low-resistance heating coils. This practice is known as cloud chasing. Many e-cigarettes are made of standardized replaceable parts that are interchangeable between brands. A wide array of component combinations exists. Many e-cigarettes are sold with a USB charger. E-cigarettes that resemble pens or USB memory sticks are also sold for those who may want to use the device unobtrusively. The increasing numbers of new vaping products combined with unrelated functions attest to a clear trend toward customization of e-cigarettes. It seems that experienced users like to adopt the e-cigarette to their inhalation needs, leading to e-cigarettes with adjusted airflow inlet using atomizer heads with different sized air holes. This is applied in the most recently introduced models, which are activated by a pressure difference when the user inhales from the e-cigarette, avoiding pressing a button to heat the device. Other interesting new e-cigarette-like devices provide a combined function with other electronic products such as a Bluetooth e-cigarette, which combines vaping with listening to music or calling friends, and another device can be used both as e-cigarette and mobile phone. Moreover, smartphone applications were introduced that track the number of e-cigarette puffs taken, calculate cost savings and increased life expectancy, and have features such as auto shutdown and password protection safety. In line with this, Philip Morris International has filed a patent for an e-cigarette that is Wi-Fi connected, and thus would be able to connect to other devices. This device could potentially synchronize to a smartphone application that is intended to help people quit smoking, and carefully track their progress. A similar product is the Vaporcade Jupiter, a cellular vaporizer, combining a smartphone with an e-cigarette. This allows the user to monitor the e-cigarette use, the e-liquid remaining, and the flavor used. As the e-cigarette industry continues to evolve, new products are quickly developed and brought to market. The early devices looked like a traditional cigarette, often including a small light on the tip that lit when the user puffed. These early systems were generally inefficient at delivering nicotine, in part because the particle sizes of the aerosol were too large to penetrate deep into the lungs. Newer versions feature replaceable or refillable reservoirs and rechargeable batteries that generate smaller particles and more efficient nicotine delivery. Since e-cigarettes are not regulated in many countries, the device designs can change often. There is wide differences in the quality of e-cigarettes, such as the airflow rate, aerosol production, and leaking of e-liquid cartridges. First-generation e-cigarettes started off as patents in periods of 1927 to 1936 and 1963 to 1998, but becoming commercially mainstream in 2003. They tend to look like tobacco cigarettes and so are called cigalikes. The three parts of a cigalike e-cigarette initially were a cartridge, an atomizer, and a battery. A cigalike e-cigarette currently contains a cartomizer, cartridge atomizer, which is connected to a battery. Most cigalikes look like cigarettes, but there is some variation in size. They may be a single unit comprising a battery, coil, and filling saturated with e-liquid in a single tube to be used and discarded after the battery or e-liquid is depleted. They may also be a reusable device with a battery and cartridge called a cartomizer. The cartomizer cartridge can be separated from the battery so the battery can be charged and the empty cartomizer replaced when the e-liquid runs out. The battery section may contain an electronic airflow sensor triggered by drawing breath through the device. Other models use a power button that must be held during operation. An LED in the power button or on the end of the device may also show when the device is vaporizing. Charging is commonly accomplished with a USB charger that attaches to the battery. Some manufacturers also have a cigarette pack-shaped portable charging case, PCC, which contains a larger battery capable of recharging the individual e-cigarette batteries. Reusable devices can come in a kit that contains a battery, a charger, and at least one cartridge. Varying nicotine concentrations are available and nicotine delivery to the user also varies based on different cartomizers, e-liquid mixtures, and power supplied by the battery. These manufacturing differences affect the way e-cigarettes convert the liquid solution to an aerosol, and thus the levels of ingredients that are delivered to the user and the surrounding air for any given liquid. First-generation e-cigarettes use lower voltages, around 3.7 V. Second-generation devices started in 2013, and tend to be used by people with more experience. They are larger overall and look less like tobacco cigarettes. They usually consist of two sections, basically a tank and a separate battery. Their batteries have higher capacity, and are not removable. Being rechargeable, they use a USB charger that attaches to the battery with a threaded connector. Certain batteries have a pass-through feature so they can be used even while they are charging. Second-generation e-cigarettes commonly use a tank or a clearomizer. Clearomizer tanks are meant to be refilled with e-liquid, while cartomizers are not. Because they're refillable and the battery is rechargeable, their cost of operation is lower. However, they can also use cartomizers, which are pre-filled only. Some cheaper battery sections use a microphone that detects the turbulence of the air passing through to activate the device when the user inhales. Other batteries like the Ego style can use an integrated circuit, as well as a button for manual activation. The LED shows battery status. The power button can also switch off the battery so it is not activated accidentally. Second-generation e-cigarettes may have lower voltages, around 3.7 V. However, adjustable voltage devices can be set between 3 V and 6 V. The third generation started in 2013, it included mechanical mods and variable voltage devices. Battery sections are commonly called mods, referencing their past when user modification was common. Mechanical mods do not contain integrated circuits. They are commonly cylindrical or box-shaped, and typical housing materials are wood, aluminum, stainless steel, or brass. A larger box mod can hold bigger and sometimes multiple batteries. Mechanical mods and variable devices use larger batteries than those found in previous generations. Common battery sizes used are 18350, 18490, 18500, and 18650. The battery is often removable, so it can be changed when depleted. The battery must be removed and charged externally. Variable devices permit setting wattage, voltage, or both. These often have a USB connector for recharging, some can be used while charging, called a pass-through feature. The power section may include additional options such as screen readout, support for a wide range of internal batteries, and compatibility with different types of atomizers. Third-generation devices can have rebuildable atomizers with different wicking materials. These rebuildables use handmade coils that can be installed in the atomizer to increase vapor production. Hardware in this generation is sometimes modified to increase power or flavor. The larger battery sections used also allow larger tanks to be attached that can hold more e-liquid. Recent devices can go up to 8 V, which can heat the e-liquid significantly more than earlier generations. A fourth-generation e-cigarette became available in the United States in 2014. Fourth-generation e-cigarettes can be made from stainless steel and Pyrex glass, and contain very little plastics. Included in the fourth generation are sub-ohm tanks and temperature control devices. The e-cigarette user can breathe in large puff volumes, which results in a significant usage of e-liquid per puff. Usually used by experienced e-cigarettes users. E-cigarette liquid, e-cig liquid, e-liquid, juice, vapor juice, vape juice, smoke juice, vaping fluid, vaping juice, e-juice, e-fluid, or vape oil is the mixture used in vapor products including e-cigarettes. Since e-cigarettes are not regulated in many countries, the composition of the liquid can change often. There is a great amount of variability in e-liquid formulations due to fast growth and changes in the manufacturing designs of e-cigarettes. Notes 1. The composition of the e-liquid for additives such as nicotine and flavors vary across and within brands. E-liquids come in many variations, including different nicotine strengths and many different flavors. The main ingredients are propylene glycol, glycerin, and flavorings, and most often, nicotine in liquid form. The liquid typically consists of a combined total of 95% propylene glycol and glycerin, and the remaining 5% being flavorings, nicotine, and other additives. The most frequently used e-liquid solvents are propylene glycol and glycerin. Flavorings may contain menthol, sugars, esters, and pyrazines. Flavor components include eucalyptol, camphor, methyl salicylate, pulegon, ethyl salicylate, cinnamaldehyde, eugenol, diphenyl ether, coumarin, diacetyl, acetoin, 2,3-pentanedione, cyclohexanone, benzaldehyde, cresol, butyraldehyde, and isoamyl acetate. Sugars are frequently used in e-liquids to provide a sweet flavor. Diacetyl, acetoin, and 2,3-pentanedione are used for buttery flavoring. Camphor and cyclohexanone are used for minty flavoring. Benzaldehyde is used for cherry or almond flavoring. Cinnamaldehyde is used for cinnamon flavoring. Cresol is used for leathery or medicinal flavoring. Butyraldehyde is used for chocolate flavoring. Isoamyl acetate is used for banana flavoring. E-liquids named coffee, tea, chocolate, or energy drinks typically contain caffeine at levels considerably less than in comparison with dietary products. E-liquids are also available with vitamins or cannabis flavors. In addition, specific e-cigarettes, mods, are available that allow for not only liquids but also herbs, oils, or fruits to be vaped. Moreover, dual-function devices handle both concentrates and e-liquids using multiple cartridges. E-liquid can be made with or without nicotine, with more than 90% of e-liquids containing some level of nicotine. The most regularly used base carrier chemical is propylene glycol with or without glycerin. E-liquid containing glycerin and water made without propylene glycol are also sold. There are e-liquids sold without propylene glycol, nicotine, or flavors. E-liquids containing THC or other cannabinoids is also sold. Specific kinds of e-liquids contain a tiny amount of alcohol. The amount of alcohol in e-liquids vary, and there are cases where it has not been disclosed as an ingredient. It is uncertain whether the nicotine used in e-liquid is manufactured using a U.S. pharmacopoeia-grade nicotine, a tobacco plant or tobacco dust extract, or a synthetic nicotine. Most e-cigarette liquids contain nicotine, but the level of nicotine varies depending on user preference and manufacturers. Although some e-liquid is nicotine-free, surveys demonstrate that 97% of respondents use products that contain nicotine. About 3.5% of users use liquid without nicotine. An e-cigarette user used approximately 3 flavors. A 2016 study showed that measurable amounts of arsenic, nickel, and other metals were in e-liquids. Over 80 chemicals such as formaldehyde and metallic nanoparticles have been found in the e-liquid. E-liquids typically contain nicotine, propylene glycol, glycerin, 1,3-butanediol, 1,3-propanediol, ethylene glycol, menthol, safrole, ethyl vanillin, camphor, alpha-thujone, coumarin, and diethylene glycol, according to a 2017 review. E-liquid can contain a range of toxicants and can contain impurities. A 2013 study found the e-liquids tested had as high as 5 times the upper threshold permitted levels of impurities. E-liquids have been found to contain low levels of some of the toxicants found in tobacco smoke, as well as small concentrations of carcinogens. The FDA in 2009 analyzed e-liquid cartridge samples which were found to contain tobacco-specific nitrosamines, TSNAs, diethylene glycol, detected 1 e-cigarette cartridge, cotinine, anabasine, myosmine, and beta-nicotyrene. The TSNAs N-nitrosynornicotine, NNN, 4-methylnitrosamino-1-, 3-pyridyl-1-butanone, NNK, N-nitrosoanabasine, and nitrosoanadabine have been detected in 5 e-liquid cartridge samples from 2 companies in levels comparable to nicotine replacement products, according to the results of the FDA's analysis. TSNAs were found in a broad range of levels. TSNAs present in tobacco smoke were also found in e-liquids, at different levels, in trace amounts. Studies in 2013 of other e-liquids had not detected diethylene glycol. The majority of the e-liquids analyzed contained NNN from 0.34 to 60.08 μg/L and contained NNK from 0.22 to 9.84 μg/L. The FDA issued warnings to several e-cigarette companies for selling e-cartridges and refill solutions containing active pharmaceutical ingredients such as rimonabant, Cymulti, for the purpose of losing weight and reducing smoking addiction, and tadalafil, the active ingredient in Cialis, for the purpose of increasing sexual capacity. FDA analyses of these e-cartridges and solutions showed the presence of aminotadalafil and not tadalafil, and the presence of an oxidative product of rimonabant, as well as rimonabant. The e-liquid often contain other substances unknown and/or undisclosed to the user. The specific origin of the e-liquid ingredients is often unclear. When content information is given on the packaging, it is usually incomplete. Contamination with various compounds in e-liquids is a result of poor quality control. Some nicotine and TSNAs have been found in e-liquids labeled as no nicotine. Nicotine content information on labels for some e-liquid companies may be vague, inaccurate, or absent. E-liquid were found to contain low levels of anthracene, phenanthrene, 1-methylphenanthrene and pyrin. Diethylene glycol, hydrocarbons, ethanol, terpenic compounds, and aldehydes, particularly formaldehyde and acrolein were found in the e-liquid. Diethylene glycol is a potential byproduct of propylene glycol. A 2014 study showed that e-liquids from a specific manufacturer contained greater amounts of ethylene glycol than glycerin or propylene glycol, which was likely a result of improper manufacturing methods. Some liquids contained residual solvents such as 1,3-butadiene, cyclohexane, and acetone. Some e-liquids contain tobacco alkaloids such as nornicotine, anabasine, or anodabine, and TSNAs, such as N-nitrosynornicotine, NNN, 4-methylnitrosamine, -1-, 3-pyridyl-1-butanone, NNK, nitrates, and phenol. Tobacco alkaloids that were identified in some e-liquids were not found on the ingredient list. Small quantities of volatile organic compounds, VOCs, such as benzene, toluene, xylene, and styrene have been found in the e-liquid. Diethyl phthalate and diethylhexyl phthalate have been found in e-liquids. Some e-liquids contain tin whiskers, microscopic crystals that originate from tin in the solder joints.